So this is the lines of charge lab. The problem here is that I need to determine the charge on a piece of tape based on a line charge model and not solely a point charge as in lab 1 by using some simple measurements like mass, length, and distance. The results of this lab overall showed that the magnitude of the charge of the tape fell within a factor of 10 to the negative 8, which is reasonable considering the range could be from 10 to the negative 19 to 10 to the 5th. And the sections I'll go over in this report include the experimental model, results from the experiment, calculations, coding, and theoretical questions. So the model used here was floating tapes again, as in lab 1, where we have two like charged tapes positioned so that one is floating over the other due to the repulsion of the like charges. And then the computational model included lines of charge where the tapes are considered to be lines of multiple point charges, similar to how we would approach a uniformly charged rod problem. And then the physics principles used in this lab include the superposition principle, which tells us that the electric force at a point in space is due to charges elsewhere. And the principle of momentum as well, because we know momentum is not changing, so therefore we know electric force will be equal to gravitational force, as we will discuss in a minute. And then the assumptions in this lab include ignoring air resistance and assuming that the charge is evenly distributed along the tapes. So the experiment consisted of two charged pieces of tapes floating one above the other, where gravitational force is equal to electric force since momentum is not changing. And then the length of my tape was about 0.2 meters, the mass was about 0.0002 kilograms, and then the distance between the tapes for floating was 0.022 meters. And then here, just to kind of simplify the momentum principle that we're using, so we know it's equal to 0, and that boils down to mg being equal to QE, or electric force equal to gravitational force. So we can then calculate gravitational force by plugging in the gravity constant and the mass of the tape, and then electric force would be the same value but opposite sign of this. And the coding in this experiment included two lines of 10-point charges that represent the floating tapes, and two larger arrows representing gravitational and overall electric force, which are the same size but opposite directions, as we'll see. 10 smaller arrows representing the electric force of the bottom tape on the top tape, because of the superposition principle, which tells us that the net force is a summation of all the points elsewhere, or the bottom tape. And the magnitude of the electric force was 1.98 times 10 to the negative third newtons, and gravitational force was the same, and they're equal again because momentum is not changing, as we saw. And then the charge on the piece of tape turned out to be 2 times 10 to the negative 8 coulombs. So here you can see where we plugged in the mass of the tape and then the charge of the tape, which was found basically with a guess and check kind of method, and it turned out to be 2 times 10 to the negative 8. I used the E-field function from lab 1 and lab 0, and then the line charge function was new to this lab, which allowed me to create the two lines of charge to represent the tapes. And then here, the for loop allowed me to create the individual arrows on the spheres and the lines of charge to represent electric force from the bottom tape on the top tape. And then here you can see it prints out two line charges, the top and bottom tape, and the yellow arrow represents gravity force, and the white arrow is electric force. And then all of the little green arrows represent the electric force on the top tape from the bottom tape, and then adding those up would be equal to the net electric force, or the white arrow, again based on superposition principle. And then the questions in this lab. So what if the model used single point charges like in lab 1? Well, the charge values would have been the same if I'd again modeled it as a point charge, but we saw in lab 1 the value was about 1.08 times 10 to the negative 8 coulombs versus the line of charge value of 2 times 10 to the negative 8 coulombs. Why do the estimates differ? Well, you're considering a single point versus multiple points contributing to the electric force and kind of just ignoring the superposition principle when considering the tapes to be a single point. Then which value is closer to the real value and why? The line of charge is closer to the real value because it does not ignore the fact that electric force is due to multiple points from multiple directions. So in conclusion, charges can be small but significant. The line of charge model is more accurate than the point charge model, and this is an easy everyday example of the superposition principle.